Alright, let's look at the practice exam 3, number 2. Right, so we are looking for the interval where f is concave down. Right, so we need to take the second derivative. Right, so take the first one first. Take the first derivative. Right, derivative of natural log is always you just put whatever inside the natural log, put it on the bottom. So 3x squared plus 1. And I take the derivative of that, put it on top. So that's going to be 6x. All right. Then we take the derivative again. So f double prime of x is equal to, right? I'll just put 6 outside, just a constant multiple, right? Then I try to apply the quotient rule. Right, square the bottom, so you have a quantity 3x squared plus 1 squared, right? And the 6 is, so derivative of x is 1 times bottom was 3x squared plus 1 minus just x times derivative of the bottom, which is going to be 6x again. All right, so if you simplify that, then you see that this is going to be 6 is in front, and the denominator is looking good already. So you have 3x squared plus 1 squared. All right, so it's going to be, this is going to be 1 minus 3x squared minus 6x squared. So it's going to be negative 3x squared. All right. Then we can just set this guy equal to 0 to find where the second derivative is 0. So this will give us, we can set this guy equal to 0. So it's going to be 1 is equal to 3x squared, and which means that divide through by 3, x squared is going to be 1/3. So then take the square root of both sides. So x is going to be plus or minus square root of 1/3. Right? So let's do a number line. So you have a number line here. Right? So you have negative square root of 1/3. And you have a positive square root of 1/3. Right? So we can just try any number less than negative 1/3. So I'll probably like negative 1. So f double prime of negative 1. Right, negative 1 here, plug it in, 1 minus 3, so it's negative. This is always positive, so it's going to be negative. Right, so you have a negative sign there. And if you try anything between negative square root of 1/3 and the positive square root of 1/3, I would probably try 0. And plug in 0, positive, 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 everyone's positive. So you have positive here. Right? Then after square root of 1/3, so I'll probably try positive 1. Then you have 1, and that's negative, positive, positive, so that's negative. Right? So in order to get a concave down shape, the second derivative has to be negative. So we know that we say, so therefore, original function is concave down on, right, you can see the interval from negative infinity to negative square root of 1/3, and also positive square root of 1/3 to positive infinity. Right? So that's the answer for part A. All right, part B, find all inflection points. So you can see that there's a concavity change occurs here. So there will be an inflection point there. Right, and also another concavity change occurs here. So there's going to be a inflection point there. All right, so x value is given, so we just have to find the y value. So f of, let's try negative square root of 1/3 is going to be natural log of, let's say 3 times. All right, you square the negative square root of 1/3, you're going to get 1/3 because you square that, plus 1, which gives you natural log of 2, right? And actually, it's going to give you exactly the same value if you plug in positive square root of 1/3, because you're going to get natural log, and 3 times square of that is 1/3. Then you have plus 1. All right, so this is natural log of 2 again. All right, so therefore, we found inflection points. There are 2 of them. All right, one is negative square root of 1/3, comma, natural log of 2, and positive square root of 1/3, natural log of 2. Those are the inflection points. All right, that's it. I hope that this was clear.